So here's a short discussion about the various combinations for the voltages apparently available from the ATX power supply in various combinations. So starting over here, we have the black lead, orange, red, and yellow, and that is starting at 0 volts, plus 3, plus 3.3, plus 5, and plus 12. And then with the blue lead, way down here, you have minus 12. And it's with reference to this black lead. So you can get between the black lead and the orange, 3.3, black to red, 5, plus 5, and black to yellow, plus 12. Now the interesting, so there's your, say, 12 volts. And between the black lead and the blue lead, you get minus 12 volts. Now here's where it gets interesting. So between the orange lead and the yellow lead, you can actually get 8.7 volts. And between the orange lead and the blue lead, you can get 15.3 volts. So it's the difference between these voltages. And here, for example, between the red and the black, you get 7 volts. So here the yellow is plus and the red is the minus. And between the red lead and the blue lead, you can actually get 17 volts. Now the interesting thing here is, in this case, the red lead is the negative voltage. But in this case, the red lead is the positive voltage. So you have to get the idea that you have this scale. Even though the 0 is in the middle, in fact, you have a minus voltage. So between the blue lead and the yellow lead, you actually can get 24 volts. Now the limitation here is the amount of current that you can get out of this. Now normally between these two you can get like 20 amps or 30 amps, something like that. But on these higher voltages that use the blue lead, it's limited to the amount of current that's available at the blue lead, and usually it's about half an amp. So a number of folks have been sort of a little bit confused about this, so I thought this diagram would help. And another way of looking at it is if you make the blue lead 0, then you've got plus 12, plus 15, plus 17, plus 24. Or if you make the plus 12 volt lead, or the yellow lead, the 0, then everything becomes negative. So it's all relative to where it is on this scale. So hopefully that sorts out some of the combinations that are available. I found this useful. You can, for example, use the 15.3 lead, or combination rather, to charge a 12 volt car battery. It's normally about 14.2. So the 15.3 will trickle charge it. So it doesn't really do that much. I've used the 17 volt combination to charge the 14.4 volt NiCad batteries. And the 24 volt lead, I have to put a series resistance in there to limit the current, but I've used that to charge an 18 volt NiCad battery. So there you have it.